Hello, let's learn how to address this question of rate of change. So please pause this video and read the question once. Okay, so here they're saying that the radius of the balloon is increasing at a rate of 1 centimeter per second. So radius of the balloon is increasing from 1 centimeter per second. Um, per second, so which means that it is dr over dt, that is equal to 1 centimeter per second. Okay, now if you look at the first question, find the rate at which the pump is working, or it is a rate of change of volume. Okay, so what is that we have to find out? We have to find out dv by dt. Okay, so what is v? It's a spherical balloon, so it is 4 by 3 pi r cube, and then dv by dt is equal to sorry, first you have to find dv by dr, because r is the variable here, dv by dr, which is equal to 4 by 3 pi times 3r square, which is equal to 3 and 3 will get cancelled, so it is 4 pi r square. Okay, so this is the first step. Now what you have to find out? You have to find out dv by dt. So how will you find dv by dt? Which is dv over dr times dr by dt. Okay, so we should know this formula, that if it is dv by dt, we can differentiate it with a different another variable here, and then differentiate the second variable with the one which we have to find out the value with. So that's the formula which I have done here. Now here what you have to do is like dv by dt, dv by dr is equal to 4 pi r square times dr by dt is 1. Okay, then that is equal to 4 pi r square. Okay, so that is one step. Now the question is, uh, find the rate at which the pump is working. So here they have said that when the length of the radius is 2 meters, so they have mentioned it in the question, the length is 2 meter. So here we can write that when r is equal to 2 meter, dv by dt is equal to 4 pi into 200 square. Yeah, because this is meter and the other is when you have to put it in centimeter, this is 200 centimeter, and that will count to 160 pi centimeter cube per second. So this is for the volume. Okay. Now let's look at the second question. Second question says, if the air continues to be pumped at this rate, find the rate of change of the radius when when it is 5 meter in length. Okay, so now in this case, where the air continues to be pumped at this rate, so you have the dv by dt here, which we have calculated, which is pi centimeter cube per second. And what is that you have to find out? Find the rate of change of radius when it is 5 meters. So you have to find out rate of change of the radius when it is 5 meters in length. So here what you have to find out is dr by dt. Okay, so then again dr by dt is equal to dv by dt into dr by dv. Okay, you can put this as a formula. So that again you can say that it is dv by dt is 60,000 pi times dv by dr by dv we don't know, but dv by dr we know, it is 4 pi r square. Okay, so then that will be 1 by 4 pi r square. Okay, then you can simplify this as, okay, you can further simplify this and you will get it as 4 over 25, which is equal to 0.16 centimeter per second, because you are going to put the value of r as 5 meter, which is 500 centimeter. Now moving on to the third question, at what rate is the surface area of the balloon increasing when r is equal to 5 meter? So now we have to go to the formula book, find the surface area, and you will find the surface area is equal to 4 pi r square. So then dA by dt is equal to dA by dr times dr by dt. So you're introducing a new variable so that you can find out the calculation. So that is equal to dA by dr into what is dA by dr? dA by dr is equal to 4 pi r square. So 4 pi into 2r, so which is equal to 8 pi r. And then you can write this as 8 pi r into dr by dt is 0.16, which we calculated before. So then you have to calculate it for the r when r is equal to 5 meters, so 500 centimeter, and you will get this as 640 pi centimeter square per second.